Okay, so this is going to be part 2 of the water resources notes. This is right where we left off. We're going to talk about ways to, unconventional ways to get fresh water. And so one of them here is called desalination. We've already talked about how most of the water on this planet, 97% of it, is salt water and it's undrinkable. We have certain places in the world that really don't have a whole lot of access to fresh water, and they have plentiful salt water. So this is a viable solution for them to get fresh water. So this is called desalination, and it's just a process where you're removing salt from salt water to get fresh water from it. It says this process is used by some water-poor countries to obtain fresh water. The Middle East is probably the area of the planet that uses this process the most. And it says countries of the Middle East produce 50% of the world's desalinated water. The problem with this is it can be expensive. So obviously, and you have a lot of areas in the Middle East that have poverty, and we also have this issue in Africa as well, getting them clean, fresh water. So hopefully this is a technology that will increase in the next several decades, and it will become less expensive and more readily available to people. So anyways, there's 2 different ways to do this. You can do what's called distillation, which is you just boil that water. You boil the salt water, which is going to leave the salt behind, and you collect the fresh water in the form of steam, and then that's condensed, and then it turns back into water, and then we have a nice supply of fresh water, and I'll show you a picture of that. And then you can also do what's called reverse osmosis, where water is forced through a thin semi-permeable membrane at high pressure. This is some review of your biology stuff. And this process is going to separate the water from the salt because the salt particles are going to be larger than water, and the salt can't fit through the membrane, so it's going to isolate the fresh water from the salt. Okay, so this is the first one, which we call distillation. What we have here, it shows, it says your seawater flows into your chamber up here. Your heating element is going to boil water, creating steam. So it looks like we have your boiling chamber here. This is going to cool seawater in condensing coil, and that causes steam to condense. So you've got your condensing coil up here. You're boiling the water. The steam rises up. It's going to collect here on this condensing coil. And so then once it condenses, the salt will fall back down here, and the fresh water will fall over here to this side. So it says your salt-free water is going to flow out of the chamber once it's condensed and fallen back onto this side. And then, so this is your salt-free fresh water over here. And then we call the waste over here, we call it brine. It's very salty water. It's going to flow out of the chamber on the other side. Okay, so boiling salt water, that clean fresh water evaporates and condenses on here, falls down, and we collect the clean water over here. Reverse osmosis, here we have seawater flowing into your chamber on this side. Pressure is applied to the water and pushes it through the semi-permeable membrane. Only the fresh water flows over to this side. The salt stays back here. Again, this really highly concentrated salt water is called brine. That would be pumped back out this way. Okay, so only fresh water is collected over here, and you could collect this to use for fresh water. Okay, water needs and uses. So obviously we need water to survive. It says no one can survive without water for more than a few days. So, depending on your body composition, you can survive without food for maybe weeks, maybe. But water, you can't survive for more than a few days without water. Okay, and it says the UN estimates that 1.2 billion people live in regions that have a scarcity of water. And we talked about that with our last notes. We said, billions of people don't have fresh water, and then we have millions of people who die from diseases caused by lack of fresh water all the time. Our main freshwater usages worldwide would be 70% of it goes to agriculture, so we're going to spend a little time talking about that, and the other 30% is split between industry and household use. That's usually a 20-10 split, where industry uses more than households. And then an interesting fact is that in the U.S., producing 1 kilogram of beef requires 11 times more water than producing 1 kilogram of wheat. So that goes along with our notion that it's better to eat lower on a food chain for many, many reasons, even when we're talking about water needs. Okay, a lot less water needed lower on the food chain. Okay, so as we just said, agriculture is the largest user of water worldwide. We're getting ready to look at various types of irrigation, so I'll explain those first, and then we'll come back and look at these pictures. Oh, and by the way, in the U.S., approximately 1/3 of all of our fresh water is used for irrigation in agriculture, so a lot. Okay, your different types of irrigation for farming. You can do what's called furrow irrigation. This is going to be the least efficient, and that's where you have a trench that is flooded with water. Flood irrigation is the entire field is flooded with water as well. So this is a trench versus the entire field being flooded. The flood one's a little bit more efficient. Spray irrigation is just like it sounds. You're using an apparatus that sprays water across the field. This is going to be more expensive. It uses more energy, but it is more efficient. And then drip irrigation is going to be your most efficient. This you're using a slow dripping hose that is laid on or buried beneath the soil. It says using buried hose is about 95% efficient, and this discourages weed growth as well. And you guys have probably all seen those hoses. We've seen them at Lowe's and Home Depot, the ones that you can't see the holes, but they've got little holes in them, and they slowly leak water into the soil. And then something that's kind of a new movement, I wish I had a picture of it, is this hydroponic agriculture. This is where crops are grown in fertilized water indoors with no soil in an indoor greenhouse setting. This uses much less water than traditional soil farming. Here they can recycle this nutrient-rich water over and over again, and it can produce more crops per hectare than traditional farms. However, this is going to be your more expensive type of agriculture, but this is kind of a futuristic way of growing crops. And you don't need soil, and you can recycle the water. Okay, so that's the furrow irrigation we talked about, where you've got these trenches that you flood. Here's the entire flooding irrigation, where you flood the whole field. Here's the spraying irrigation, which we said is a little bit more efficient than these. And then the most efficient is drip irrigation with these hoses that would slowly trickle water onto your crops. Okay, so we said farming uses most of the water. The second largest user of water is going to be industry. It says water is needed for many processes, such as generating electricity. If we're using steam and hydropower, we need water as our actual source to generate kinetic energy. It's used for cooling machinery. It's used for refining metals and papers. And we have to keep in mind that anytime we are creating any sort of goods or products, or we're using a good or product, we have to realize that a great amount of water and energy went into producing them. Household needs, as far as that goes, we know that that's the third largest user of water worldwide. If we break it down into what we're using it for in the household, it says here 41% goes for flushing toilets. We can see that here. About 33% for bathing, about 21% for laundry, and about 5% for ingesting via cooking and drinking. Okay, and then here you have per capita household water users. And it looks like Australia and Canada actually have higher per capita per person water use than U.S. So that's something where we're not the biggest problem worldwide. Okay, and then you've got a whole bunch of other ones over here. Let's move on. Okay, so more stuff on household water use. In terms of any sort of outdoor water use, we use water mostly for watering lawns, washing cars, and swimming pools. And it says this varies by area. If you go out west, it says Cali has a much higher use than the East Coast state like Pennsylvania. In terms of drinking water, it says nearly 15% of the world's population don't have clean drinking water. We've talked about that. 1.8 million people yearly die of diarrheal diseases related to contaminated water, and most of these are children, and that comes out to about 5,000 people a day, and this is supposed to be a sad face. So again, and we'll watch a little video that kind of talks about this. This is definitely a global issue, even in a developed country. It's sad to think that there are people who die just because they don't have clean drinking water. Water ownership. So I mentioned this earlier. Interesting question. Can you own water? And so here it says people can have rights to water use, but you cannot actually own this flowing fluid water. However, conflicts have been erupting over water ownership. We mentioned this case study earlier. India versus Bangladesh. We said India was upstream of Bangladesh. They are planning to divert this river that Bangladesh has received water from for centuries and centuries. Is that right? Can India divert the water? Are they allowed to do that? Do they own that water just because they're ahead in line of Bangladesh? There have been conflicts in the Middle East over water. Some environmentalists speculate that in the future, now there's wars over oil and that sort of thing. They speculate in the future there could be warring and conflict over water. Again, I don't know if we're going to have time to watch this video or not, but I've got this really cool video on water, and there's a really neat case study that's brought up in this video, and it's involving Nestle organization. What happens, I believe this is in Ohio, a company moves onto property and it pumps all of the groundwater in this farmland, and this is actually stealing a whole bunch of water from neighboring farms, and the people who live on these neighboring farms are realizing that their wells and their water is starting to run dry and run at slower amounts. So they took this to court and they said this is not fair that this company can just come in and buy land but then pump the water just because they have better, stronger, faster pumping apparatuses. They're pumping the water faster than we can get it, so they're stealing all of our water. Is this okay? They own that land, so are they allowed to take as much water as they want? Or do the other people living on the nearby farms have a case too? Should they be able to take them to court and say that they should stop pumping? Or should everybody have a water restriction, a certain amount that they can pump? So that's an interesting case study. Like I said, if we have a chance, I will show you that video clip. And then there's another interesting case study about the California water wars. It is in your textbook. I'm just trying to see if I have time to talk about that or not. No, I'll save that for class to talk about. Okay. Okay, so competition for the world's water. Cities are outbidding farmers for water supplies from rivers and aquifers. Some countries are importing grain as a way to reduce their water needs so that they don't actually have to grow their own grain where they live and use a bunch of water for irrigation. And then it says more crops are being used for biofuels, which is also increasing water demands. So water shortages, what would cause a water shortage? A drier climate, which we've said we've seen that in some places of the world. More droughts. Desiccation, which is affecting the soil, making soil drier as we have less and less precipitation. Water stress, it says lower per capita availability due to population growth. So more people and more reasons that we need water means that we've got more of a stress on our water resources. 30 countries containing 500 million people who have chronic water shortages. There is enough water, but it's often wasted, polluted, and it's in areas where it's hard to get to. And 2/3 of the world live in water poverty, where they do not have water coming into the home. And again, we mentioned this before, but we take for granted that we have plumbing in our homes, and we have when you turn on the tap, there's water there. You turn on your shower, there's water there. A lot of people who live on this planet do not have that luxury. They actually have to go somewhere and retrieve their water every day, and that might be like their main goal in life for that day is to get their water. So we definitely have it good. How can water supplies be increased? And again, this could be kind of back and forth here, but building dams and reservoirs, that could increase water in certain areas, but it might decrease water in other places. Importing water from other areas, having it diverted from another area, withdrawing groundwater, but that has to be done at an appropriate rate. Desalination, turning salt water into fresh water. Improved efficiency of using water. Okay, so let's look at some of that stuff. So for water conservation in the northeast U.S., water is abundant. However, for other places in the country, water conservation is necessary now, and if not now, it's going to be necessary in the very near future. So in 1994, our country initiated these new federal standards for toilets and shower heads. seeing this upcoming water issue that we'd be having. They've said that we need to use low flow toilets and shower heads, which use less water. We said anytime you use these sorts of things, it also lowers your water bill. So it's a win-win situation there. You can also do the brick in the back of the toilet trick, which we talked about in class. You put the brick in the tank, and that's going to raise that water level. That's going to make it so that your toilet has less water per flush. So that we said it's kind of a comfort thing. If you're okay with that, you can try it. Some toilets in Europe have the dual flushers for 2 different flush sizes. If you only need a small flush, you push the small button. If you need a larger flush, you push the larger button. The front-loading washing machines use a lot less water than a traditional washing machine. And then it says it's encouraged to, people who live in these water-stressed areas are encouraged to plant water-efficient native landscaping. So plants that don't need a lot of water, so your native desert plants. So if you go out to the southwest, you see a lot of creative landscaping. You see a lot of yards that are just rocks because they don't have grass, because that's going to require a lot of water, and they'll have these native kind of drought-resistant plants. Okay, some other ways to do water conservation: use rain collection barrels. Again, if you've been to, especially places in the Caribbean, you might see those. A lot of times they're black colored and they're plastic, and you see them on top of buildings, and they actually collect rainwater, and they use those for shower water and other things. Use treated wastewater for irrigation. So again, that happens from a lot of wastewater treatment plants. They send stuff that hasn't gone through as rigorous of cleaning, and they'll just send that to places to use for watering of land and irrigation purposes. They sell all these weird systems where you can reuse gray water within your own home. Gray water would just be water that has been just barely contaminated with like soaps and that sort of thing. So water coming from your sink would be considered gray water. Water from your shower would be gray water. So an example of this is you could reuse shower water in your yard for landscaping, and they also create these sink-to-toilet gray water systems. Again, so you've washed your hands with soap and water. This is gray water. It would collect it in a tank, and that sends it over to your toilet, because who cares what kind of water is being used in your toilet? So you just get your leftover sink water as toilet water. Okay, here's some other things that we can do to help with water conservation. Not withdrawing too much groundwater and not depleting aquifers. Let me see if there's anything new we've talked about. Okay, agreements among regions and countries sharing surface water resources. Outside party mediation of water disputes between countries, so that goes along with those diversion case studies we talked about. Marketing of water rights, could people have the right to divert water if it's going to affect a lot of other people? Wasting less water, slowing population growth, that's a big one. Okay, so, and then the last thing we'll talk about are floods. I mentioned this a little bit earlier. A floodplain is what we call the natural overflow area of a river. These are usually very productive areas that have very fertile, nutrient-rich soils, because when water overflows, it's going to carry a lot of sediment and nutrients with it. Floods are a natural thing. They enrich the soil, they recharge groundwater, and they refill wetlands. So, historically, flooding has been a good thing. People just knew not to build homes and stuff in a flood area, or else they're going to have to deal with that. It says humans make flooding worse by removing vegetation, draining wetlands, and living in floodplains. They just kind of set themselves up for a bad situation there. I've got some pictures of that. So this is what we would call a floodplain. You've got your river meandering through here. You can see where you would traditionally have flooding. You can see all these sediments that have probably been laid down from previous floods. What humans have done, we come along and we straighten that river out. We create these levees on the sides, these flood walls, and we're like, okay, now we're good to go. We can go ahead and start building stuff around this area. Even though it's a floodplain, we've got these levees. They should protect us. Here we've actually dammed up the river and made a reservoir here. Well, if we happen to get a flood, this is what would happen. Water can break over the levees, which is what we've seen here, and then it's going to affect people who live in this floodplain. So again, a lot of experts say you should not be building in these floodplains, but we have been doing that. Okay, and just the last couple slides to show you what happens when you remove vegetation. So this is showing a nice slope. You've got all these trees and vegetation in place. Normally you've got precipitation occurring, and then you've got evaporation that's happening. You have transpiration happening from your trees. Let me see what this says here. Yeah, lots of oxygen being released by all of your plants and vegetation. Your soil is going to be nice and spongy and porous, so it's going to be able to allow water to infiltrate. And so you've got a nice steady flow of water. You've got a steady river flow here. This is a type of situation where you would have reduced erosion and water would be able to easily infiltrate the land. However, once you remove all those trees, it's showing now you can have landslides and gullies. Gullies are like these little pits that kind of form here in the ground. You can have heavy rain leaches. They're going to leach nutrients from the soil. They're going to erode a bunch of that soil down the hill. Here it shows silt from erosion blocks rivers and reservoirs and can cause flooding downstream here. Rapid runoff issues. So, lots and lots and lots of cascading issues from removing that vegetation, especially on a slopey hill like that. The soil, we know once you remove vegetation, the soil is going to become drier and more compact. It's not going to allow water to infiltrate it as well. So again, you'd have a higher chance of flooding down here. All right, so that is it for our water resources notes, and I believe this concludes all of our water notes as well.